Okay, so hello. I'm Ethan, and this is Scouting and Statistics. So first, Spectrum goes to FRC events. What's the goal? Anyone? Felipe?
Oh, say a question to us. Um, the goal is our goal. I guess the main goal is to win, right?
The goal is to win. The goal is to win. When we go to events, the goal is to win. And there are lots of factors that we would need to do in order to win. But for today, I'm going to narrow it down to alliance selection. What is the goal of alliance selection? So in short, the goal of alliance selection is to win. The goal is still to win. And what that means is because our original goal is to win, alliance selection should be to make decisions that cause us to win. So when it comes to, in fact, any decisions when we're at competition, picking, accepting, declining, all these actions, you have to evaluate them within the context of your goals. So evaluate decisions within the context of your goals. So things like pick the alliance that scores the most points is good, but winning isn't I just score lots of points. It's I score more points than my opponents. So picking an alliance that is good against other alliances that cause you to win, as opposed to like if you score lots of points and they score lots of points, you don't win the match. That's not the goal. The goal is to score more points than your opponent to win. So how do we decide who to select? Because of the structure of competition, where we have quals and then we have elimination matches and alliance selection, in order to know how they will perform in elimination matches when we pick them, we need to look at how they performed in qualification matches. So this is called scouting. Scouting is we look at the qualification matches, we look at what they do, how they do it, and we use that to predict how they're going to perform in elimination matches. So there are two main ways that we scout: qualitative observations. So that's their driver awareness, their driver skill. Like this could be like how well they drive, how well they play defense, how well they play when defense is on them. And for us, we take notes on for each of the teams on these things. And the second way that we scout is objective data, and this is numerical values. That is how many game pieces they score, did they climb. It's these values that are objective to the match. So statistics, I guess for us, is evaluating this objective numerical data to predict how teams will perform in elimination matches. So when the data comes back, it's a huge spreadsheet just full of numbers, and it'll be like team number, it'll be the match, and then it'll be like all these numbers for all the things that we did that we choose to write down and measure in the course of the match. So there are many things we can do to evaluate this data to see how to predict the performance of these teams. Sum is when you add numbers together. So central's tendency is the idea of like what center does the data tend to go to. So it's a single value that's a summary of data set. And so there are many examples, like mean and median are both examples of central tendency. It's what the central tendency. So one of the measures of central tendency that we use is arithmetic mean. We just call it average. It's when you add up all the values and divide by the number of values. So 1 plus 2 plus 3 plus 4 plus 5 is 15, divided by 5, number of values is 3, the average is 3. Median is also a measure of central tendency. It's the value that's in the middle. So if we have this set right here, 1, 3, 6, 8, 3, 8, 4, 7. So you can imagine crossing numbers off on each side. So you cross with the 1, you cross with 3, 8, 4, 7, you cross with the 3, you cross with the 8, you have 6. 6 is the median, it's the term in the middle. And when there's an odd number of terms, it's the term that's in the middle. When there's an even number of terms, it's after you cross off enough numbers, you have 2 in the middle, and you just take the arithmetic mean of those two values. So in this bottom example, the median would be 5.5. Minimum and maximum. Minimum is the lowest value in a set, and maximum is the highest value in a set. So in the set right here, the minimum would be 8, and the maximum would be 14. Quartiles. Quartiles are markers that are at the quarters, and this will be important later. The minimum we just went over is the lowest value, so that's like the 0%. Quartile 1 is at the 25% mark. and then quartile 2 is the 50% mark. Quartile 2 is also referred to as the median, and then quartile 3, the max value. This is called the 5-number summary. And what this can be used for is box plots that we'll get to later. So the 5-number summary, let's say we have this set right here. How do we find the 5-number summary? So first we would want to find the median. So I've like done weird things to these numbers on each side so that you can see. And the median is in the middle of these two 9s in here. So the median would be 9. And in order to find the quartile 2, quartile 2 is the median. In order to find the quartile 1, we would perform the same like median operation to the 6 numbers on the left. So we cross out the 4, cross out the 9, cross out the 6, the 8, and then you have the 6 and 7. And you do the same thing on the right side. And the 5-number summary is, this is what it would look like for this data set. What we can do with 5-number summary is create a box plot where it just graphs this. And what we can do is we can have multiple box plots. And if we put them all in a graph, we can visually represent this large data set on one graph in meaningful ways. So box plots can tell us things. Let's take, for instance, this box plot. Let's say a team scores. This is the box plot for game pieces that a team scores. There are certain things in here that tell us. So, for instance, from the 2 to the 6, 25% of the data points. So if it's 12, that would be 3, are between 2 and 6. And because 6 and 7 are really close together, we know that there are 3 data points in there. So there's going to be more data points between the 6 and there's the same amount of data points between 6 and 7 as there is between 7 and 20. So we just know that there's a higher concentration of data points between 6 and 7. And because 20 and 38 are really spread apart, we know that the range of that from quartile 3 to the max is going to be a lot larger. Interquartile range is the range between quartiles 1 and 3. So if you look at a box plot, that's the part that's a box. So here that's between the 6 and the 20. And this will be important for later. So one of the concepts of central tendency is resistivity to outliers. So outliers are abnormal data points in sets. There'll be times when teams score an abnormal number of game pieces that it's very unlikely that the same number will be scored under normal circumstances in the future. And it's not like we ignore them. We have qualitative notes, so we take those into account. But when just looking at trying to find a central tendency for all the teams to compare, we'd rather not look at some of these values. Many times that's going to be a team that maybe scores like 4 or 5 game pieces. They'll score 0 in a match because they might have like tipped over or their robot died. And in these cases, it doesn't make sense to like use an average where like the 0 gets counted and that counts against them. So mean and median differ in their resistivity to outliers. Median, you can imagine, because you're crossing them off, it doesn't matter what the values are. We saw with the 3847 that the value was really large, but median didn't care. It just got crossed off to reach the middle. Whereas mean, if you took the mean of a value that has lots of outliers, then it's going to be more skewed by those outliers. So one of the things that we at Spectrum came across a couple of years back was trimmed mean. This is what they use in like Olympic judging, where you drop the highest, you drop the lowest, and then you take the average of the rest, so that if there is like an extreme outlier, it gets rid of it. So for instance, 1, 4, 7, 7, 8, you would cross off the 1 and the 8 because the 1 is it's a weird number. If you did account for the 1, then the average would drop, whereas the median would be 7. So the thing that Spectrum's go-to measure of central tendency is interquartile mean. And what that is it's a subset of trimmed mean where 50% of the values are trimmed. So the 50% total is trimmed. So 25% off the top is trimmed and 25% off the bottom is trimmed. So that means the interquartile range, which is that middle 50% between quartile 1 and quartile 3, is what you take the mean of. So it's called the interquartile mean. That middle 50%, you take off what's on either side of that, and then you take the arithmetic mean, the average of that, and that gives you the interquartile mean. And that's about it here. I'm going to hop over to the spreadsheet. And so here are, I guess I'll just do some general spreadsheet things. So One thing you can do is if you have like team one and you want to like write all the teams, you can just drag this little corner and it does this for you and it numbers them in order. So here's random sets of data that I got. This is game pieces scored in 2019 at champs for some random teams. And so I'm going to take the mean of each of these and write all these values in, and then this allows us to easier compare them. So for mean, it's you type in equals average, and then open parentheses, and then you just select the data, and this gives you the mean. And if you drag this corner, it'll do the same thing to where it just selects within the same range, just translated because you've translated the cell over the median. You can do the same thing. And then for IQM, this is the trimmed mean. So trimmed mean. And because we're trimming 50% off, it's 0.5. So here we have all these numbers. And then now we have like this row here of what their interquartile mean of game pieces is. And we also have mean and median. And then we would just use these numbers to compare. So this team's numbers appear to be higher than like this team's numbers. So that probably means that this team is more likely to score more game pieces if we pick them than this other team is. Yeah, that's about it. Anyone have any questions?